Subtracting rational expressions. Subtracting always follows the same rules as adding, so for the case of fractions and rational expressions, to subtract them we must have common denominators. So we're just going to jump right into some examples, and we're going to see that the trickiest part when subtracting rational expressions is just to watch out for negative signs, because it's really important to follow the rules of negative signs in these problems. Be very, very precise with your negative signs. So the first fraction, I have to factor the denominator. It's a difference of squares. So I have 8y over y minus 4 times y plus 4. In the second fraction, I have 4 over y minus 4. So looking at these two fractions, I see that they both have the y minus 4 in the denominator. But the second fraction is missing this factor of y plus 4 that's present in the first fraction. So I have to multiply the second fraction by y plus 4 on the bottom, which means I'll have to do it on the top. But that will give the two fractions common denominators. So I'm going to do this first example with lots of intermediate steps, so that we can really follow what has to happen with that negative sign, which is that I have subtract 4y plus 4. This subtraction sign in the middle of the two expressions really belongs to the terms in the numerator. So if you were to have, 3/4 minus 1/4, you'd go down to 2/4. So you subtract the numerators from each other and the denominator stays the same. So this would be 8y minus 4 times y plus 4 up top. So you see that this minus is basically applying to that whole numerator there. So then I have y minus 4 times y plus 4 on the denominator. And now I'm good to go ahead and simplify. I'm going to start working to the right here so that I have room. So I have 8y minus 4 times y plus 4. So I have to get this negative 4 into, sorry, I just did a little eraser error there. I have to get this negative 4 into each term in order to simplify it. So I have negative 4 times y is negative 4y, and then negative 4 times positive 4 is negative 16, all over y minus 4 times y plus 4. And simplifying this, 8y minus 4y is 4y minus 16. And it looks like I have some simplifying I can do here. There's a common factor of 4 on the top, so that would be 4 times y minus 4, just factoring the numerator, and y minus 4 times y plus 4 on the bottom. And look at that, I'm going to get some cancellation. Y minus 4 on top and bottom cancel out, leaving me with my final answer of 4 over y plus 4. So in this problem, I got some nice simplification at the end and was left with a nice simple little rational expression there in the bottom. I'm going to run through another example here. Just like with the addition problems we saw, the first goal is to factor the bottom. So these are simple trinomials, which is nice. So I have a plus 1 times a plus 5, and in the second one, 3 over, this would be a plus 2 times a plus 5. So the missing part in each denominator, well, the a plus 5 is there in each denominator. So I've got to give the first fraction the a plus 2, and the second fraction the a plus 1. I'm actually going to show you an alternate way to do this. It's just a slight alteration, which is that actually in this step right here, I'm going to multiply my numerators out. So I have 4a plus 8, and then I also have over here over, and I have my 3 terms in my denominator, subtract 3a, so I'm going to multiply the 3 in, 3a plus 3 over my 3 denominators. Now what I really want you to notice is that this negative here applies to the entire numerator of the second fraction. So it applies to the 3a, and it also applies to the positive 3. So you're welcome to expand out the numerators in this step, just like I've done in this example, but make sure that that negative applies to both terms, or all the terms in the second numerator. So when I go to combine these fractions, I have 4a plus 8 minus 3a minus 3. So that you see that negative applies to each term in the numerator. And then I have my 3 terms in the denominator, my 3 factors down there. Gonna combine these terms in the numerator, so I have 4a minus 3 is a and then plus 5. That was probably harder than it should have been, but we all have slow days. And then in my denominator, I have that common denominator that we figured out early, which is a plus 1 times a plus 5, or sorry, a plus 1 times a plus 5 times a plus 2. And look at this, we have some cancellation that's going to happen. A plus 5 in the numerator cancels with a plus 5 in the denominator. And because the whole numerator canceled away, we still have a factor of 1 there. So my simplified answer is going to be 1 over a plus 1 times a plus 2. And that's my final answer. So this last example is just like one we saw earlier with the multiplication and division problems that we've done previously, where we have this sort of combination of 2 functions, h of x. This function is a combination of f of x and g of x. So h of x would just be f of x, which is x plus 5 over x minus 2, minus g of x, which is 5x plus 18 over x squared minus 4. So I'm combining my 2 functions through subtraction, and I can go ahead and start this problem, which now turns into just a regular subtraction of rational functions problem. And to do that, I have to factor any denominators that aren't factored. Here we have a difference of squares, so that would be x minus 2 times x plus 2. And right away I can see that we have that x minus 2 in common, but this first fraction needs an x plus 2 in order to add them together. So I actually have to FOIL these binomials in the first fraction, x plus 5 times x minus 2. So that would be x squared plus 2x plus 5x using FOIL plus 10. And then subtract 5x plus 18 from the numerator of the second fraction. So again, I'm just showing you slight alterations in how you can demonstrate that subtraction of the second fraction. X minus 2 times x plus 2. So this time what I've done is I've taken this minus and I've applied it very directly to the whole numerator just by writing it as minus 5x plus 18 all together. And now again we can see how that negative has to be applied to each term in the numerator. So I have x squared plus I'll combine this 7x plus 10 minus 5x minus 18 over my denominator. And so I can combine these guys together, x squared plus 2x minus 8, and that might be factorable. Two things that multiply to -8 and add to 2 would be -4 and 2, positive 2. Oh, no, I have to replace those signs. +4 and -2. That would be x plus 4 and x minus 2 multiplied to -8, add to 2, good, over my denominator, which was x minus 2 times x plus 2. I don't know why that changed to green. Didn't switch my pen color back. That's okay. Now I'm just looking for any simplification that can happen, and those x minus 2's cancel, which leaves me with x plus 4 over x plus 2. So that's my function h of x.